Okay, I want to show you how to calculate a discrete random variable. Now, here we have a question to tackle. The table below gives a probability distribution of a discrete random variable x. Given that p x less than 12 is equals to 0.70, find the value of q, k, and hence calculate ex squared, variance, and standard deviation. So on our table we are given the values of x and the px. Now we start from here where we are given the range x less than 12 is equals to 0.70. On our table 4, 8 and 11, they are our x which are less than 12. Now we want first to calculate the k. So our values which are less than 12 are 4, 8 and 11, which are equal to 0.70. And now we want to find the value of k. So we have k plus 0.2 plus 0.4. We equate to 0.70. We find the value of k is equals to 0.1. Now let's move forward to calculate the value of q. We have our k. Here it's easy. All the values in the p probability of x, it should give us 1. Now here we have k plus 0.2 plus 0.4 plus q plus 0.1 is equals to 1. And we have our value of k. We substitute, so we have 0.1 plus 0.2 plus 0.4 plus q plus 0.1 is equals to 1. When we add our value, we get 0.8 plus q is equals to 1. Now we subtract 1. We subtract 0.8 from 1, we get 0.2, a value of q. Let's proceed. Ex. Now we are going to calculate ex. The formula for ex is equals to summation of x times px. Now we have this in our table. You just multiply 4 times k, 8 times 0.2. We have the values. Now we can substitute. So we have 4.04, 4 times 0.1, 8 times 0.2, 11 times 0.4, 15 times 0.1, 20 times 0.1. Now the total is 11.4, and that's the answer for ex. Yeah. Now let's proceed to ex squared. We square the x. Okay, we have our formula here. It's summation of x squared times probability of x. Now x squared, we have our value of x here. We square all of them, then you times the, like, 4 squared times k. Now 4 squared is 16. 16 times 0.1. 8 squared is 64 times 0.2. 11 squared is 121 times 0.4. 15 squared is 225 times 0.2. And we have 400 times 0.1. Now the total is 147.8. That's how we get our ex squared. Now let's proceed to